you should recall, now I don't need everybody to comment, I don't remember this, or oh, I remember this, or I think I remember this. Like, keep those inside thoughts, right? We don't need to be shouting out our comfort level with these questions. I just want everybody to have a reminder. Okay, so iPads should be closed. You don't need your iPads out right now.
Oh, what do I need to have for the table of contents?
We'll update that after though.
Okay.
Yep. Okay, so we're just going to jump into examples. So we've got this beautiful equation here. I'm going to take a couple different steps to solve this. Go in. So the way that I guess you could say teach equations, the way that I show how to do equations is I do one step per line, right? So now I realize some of you can do like 3 steps in one. If that's something your brain can manage and keep organized, by all means go ahead. But I think doing one thing at a time to see the process will help you when we get into super complex equations, right? So that's going to be the strategy that I show you. So the first thing I'm going to do is distribute this 3. Anytime you see parentheses, you distribute, right? That should be your very first order of operations. So something that you guys all know, please excuse my dear Aunt Sally, right? And I don't hate it because it worked really well when I taught 4th grade, but you guys like cling on to that for dear life, and by the time you get up to 8th and 9th grade and 10th grade math, it's like you kind of have to be willing to think beyond just what those actual words are, right? So you have been taught please is parentheses, right?
Or PEMDAS.
Yeah, PEMDAS.
PEMDAS is what I always.
Yeah.
Right, PEMDAS is please excuse my dear Aunt Sally, right? So we could have parentheses, we could have brackets, we could have braces, okay? All of those things, this should really be called grouping symbols, not necessarily parentheses. But when you're in like 4th grade, 5th grade, you're not using brackets or braces yet. Those are just different math grouping symbols, right? So this should actually say grouping symbols, right? And then we have exponents, which is pretty self-explanatory. And then this is where it gets really tricky. And this is going to be something that math teachers battle forever. Okay, so what's the M and the D stand for?
Multiplication, division.
Okay, so what do you do first?
Whichever one comes
One
first.
on the left.
Left to right.
One on the left.
Left to right. How many people were thinking, oh my gosh, I thought it was multiplication always? It's okay.
No.
Oh my gosh.
No.
Listen, that has been my battle forever, right? So it's multiply or divide. Left to right, whichever one comes first, okay? So when we get into order of operations and students are like, well, the multiplication was on the right, but that's what I'm supposed to do for, no, you're not, no, you're not, no, you're not. Nope, it's left to right, like you read, okay? And then our last ones are add or subtract, again, left to right, okay? For some reason, most elementary teachers leave out this whole left to right thing.
No,
And so
No.
maybe yours didn't, in which case high five to those teachers. But this is a continuous battle I've had for the last 12 years, right? So if yours didn't, awesome, you are ready to go. But some people just memorize multiply, divide, add, subtract, and it's like they can't budge on it, okay? So anyway, parentheses should really say grouping symbols, exponents. We've got order of operations ready to go. So when I distribute this, that means I'm multiplying, right? So I'm going to have 3 minus 3x plus 3 equals negative 8. Because that negative stays with the x, 3 times negative x gives me negative 3x. what should be my next step here? This is where we kind of can go at our own path. This is where our journeys might diverge, right? What would you do, Zane?
Add the 3s.
Add the 3s. I'm going to combine my like terms, right? And I have to stay on the side of the equal sign. Did you guys have a teacher that did like wall of equality?
Yeah.
Right? Mr. Yoder, man, he's famous for that. Okay? So anything that's on the same side of the equal sign, you have to combine. So 3 plus the 3 gives me 6 minus 3x equals negative 8. Okay, but now is where I have to go across that wall of equality. So what is that phrase we use? What do we do to move it, right? How do I move this 6 from over here to be over here? Because I have to try to balance things out. Harsha?
Subtract 6 from
Yep. So I'm doing the inverse operation, right, which is the opposite. So how did you know you were supposed to subtract this 6? Because it's positive, right? So you do the opposite of whatever that value is. So I'm going to subtract 6 from both sides. I'm going to cross this out because now it's gone. I'm left with negative 3x equals negative 14. Now what do I do, Jack? Divide by negative 3. So I'm left with x equals what?
4.66.
Ooh, you guys are killing me.
Yeah.
Who said 14 over 3?
I did.
Thank you. 14 over 3. Remember, we're going to try to stay away from those decimals. Who can tell me why this is positive? Why is my final answer positive? Carson. Negative divided by negative is a positive. Fantastic. And yeah, this is gross. It's not an even number. Like it didn't simplify to a nice whole number, but it's fine. We'll be fine. If I can hear you, so can the computer. You know what that means?
Cotton 4K.
It means whoever is going to watch this video for help is going to hear your little conversation in the background and be like, I wish that kid would stop talking.
I'm sorry, kid. Hi,
I'm
Daniel.
sorry, kitten.
It's Daniel.
Daniel will have to watch all this.
Daniel's at home,
That's what I thought you said.
hopefully getting better. I'm just assuming he's not feeling well because he hasn't been here. Okay, here we go. Here's another one. 6 minus 3x plus 2 minus 5x equals 12. Coming around to make sure you guys have everything written down that I have written down, right? Gonna guarantee that you have all your resources you need. Okay, what's going to be my first step here? I'm kind of trying to trick you, but what's going to be my first step, Zane?
Multiply the negative 6 to both the numbers in the parentheses.
Negative
Nope.
1.
6
Nope. Cohen?
Negative 1.
It's actually a secret 1 hiding there, right? So I have this negative 1 right here that's hiding in plain sight right there, and that's what I'm going to distribute. I know, right? Oh.
Why am I such a donut?
What?
I'm a donut.
A donut?
Yeah.
I don't know what that
I
mean.
feel like Gordon Ramsay calls.
Yeah, Gordon Ramsay does that.
It's a friendly.
He calls people donuts?
No.
Oh, yeah.
It's donuts. Donuts.
Is it like, okay, so now we're going to distribute
Nope.
right? So I get 6, I get negative 3x minus 2, okay? If you're going to make a mistake in equations, it's going to be with distributing those negatives, right? Because somewhere along the way, you lose a little, like a millisecond of concentration, and then those negatives and positives are mixed up,
Shouldn't it
right?
be -1?
Yeah, so I distributed the -1, so -1 times 3 is -3.
Yeah, but instead of being negative, shouldn't -2, it should be -1. Right?
Nope. -1 times 2 is -2. Yep. I know, that's why we're easing our way back into these equations, because the actual math you guys are far past. It's just this process that we're focused on.
Oh, yeah.
So now I've got some like terms. I'm going to draw my wall of equality. So I'm going to do 6 minus 2, and I'm going to get 4 minus 3x minus 5x equals 12. Remember, I'm just doing one step at a time.
Shouldn't you combine the 3 and the 5?
I'm doing one step at a time. So I combined the 6 and the -2 first, and now I'm going to combine the -3x and the -5x. Right? I just show, but if you can do more than one at a time, by all means, I'm not going to stop you, but I like to show the process one step at a time. So now I have 4 minus 8x equals 12. Right. You okay?
Yeah.
Now I'm going to cross that wall of equality. So what am I going to do with this 4? Subtract it from both sides. This is gone. -8x equals 8. Think about all the time it took last year for you guys to learn all these different steps, and we're just doing it all in one day today.
It's easy. I mean,
Well, it should be, right? You spent a lot of time last year. It should be something that is just like floating around in there,
easy.
waiting to be used.
So easy, someone hard.
Very nice things.
X equals -1,
Yes, I'm right.
right?
Let's go.
Does anybody have questions? Yes.
Just about the when you just like distributed it from -1, where there's like it's 6 minus 3x minus 2.
Mhm.
Would it instead of like I always thought it was you keep the adding sign and it's just like -3x plus -2.
Yeah.
So you can't. Yeah. So I distributed these, but this negative changes the symbols that are going to be here. Is that what you're asking?
Yeah, that's
Right? So then when I combine them, this 6 and this -2, 6 minus 2 becomes 4. -3 minus 5 becomes the -8x.
It's just about that.
Oh, it's just about the distributing thing?
Yeah.
Yeah. So we just have to follow the rules of
Is that like an actual rule? Whenever you-
negatives and positive. Yes.
Because I feel like last year I didn't follow that.
Yeah, we saw that.
Your teacher may have explained it differently than like a secret hidden one, but I'm sure you had to follow it.
Yeah.
But they might have just shown it a slightly different way. But I always find if you show the -1 there and circle it, it becomes more of like an eye catcher.
Yeah.
Yep. Okay. Let's move on to everybody's favorite variables on both sides.
Yay! I love math. And why even don't have to. Do you have to be on advanced math?
I don't think so.
I mean, it's not like a rule, but if you're on that track, you should probably stay on it. Yeah. So right away, I'm going to go ahead and draw my wall of equality so that I can keep track of where the variables are. So when I teach pre-algebra, this is usually when the wheels fall off completely. We're cruising along, we understand distributive property, combining like terms, and then as soon as I have variables on both sides, it's like the connections are no longer made, right?
It's literally the same thing.
Yeah, I understand. Trust me, I know, but sometimes it's kind of hard to visualize it when you're going across and you have variables, right? So I'm going to do my distributive property on both sides, so I'm going to get negative 9x plus 18 equals 4x minus 60. So here's where we get to the choose your own adventure part of this process. Okay? Because you guys know what choose your own adventure books are?
Yeah.
Yeah?
My mom bought me.
I don't read.
Yeah. So, my boys, when they were like 3, well, my oldest was like 3 or 4, we got these books called What Should Danny Do? You guys heard of those or have a little sibling?
Daniel?
So it's like this little boy and his dad gives him this cape and it's like the power to choose, and so like it's all pictures and everything, and so he's making choices throughout the day, and it kind of just determines if he's going to have like a good day or maybe not a great day. So my boys thought it was really funny to pick the bad choices. It doesn't matter. They still learned. They knew it was a bad choice. That's all that mattered. Yes.
Was it based on a true story?
No. Right? So you kind of get to choose your own adventure. The outcome usually is the same, right, by the end. So this is where this is where your work might not look like mine anymore. And I genuinely I'm not going to count you wrong if we go in different directions here. As long as your work is accurate, what you choose to do is mathematically correct, and you get the right answer, right? So here's what I mean by choose your own adventure. When it's time to have variables on both sides, you have to decide, do you want to move all of your variables to the left, or do you want to move all of your variables to the right?
Move them all to the left.
Okay, here's my advice. Here's my advice. Avoid negatives at all costs. Negatives just mess things up. That's where you're going to maybe make mistakes because you forget the rules. So I would add 9 over here, so I have a positive 13x. If you subtract 4, which is fine, you're going to end up with a negative 13x.
Not fun.
You will still end up with the correct answer because you're going to force the positive or the negative for the other term, but it's your choice. So like I said, I'm going to add 9x to both sides. So this is now gone, and I have 18 equals 13x minus 60. And then I just have a 2-stepper, so I'm going to add 60 to both sides. Divide by 13 on both sides. 6 equals x. Yeah?
Stared at her after she was like, yes, and you go. Was this
How are we feeling about this? Yeah?
magnificent?
Okay. We're all wheels are still on. Ultimately, I usually have students that say, why do I do my x's like this?
Yeah.
Right?
Because it's math.
Well,
It can get confusing
I-
with multiple.
I think I must have had, it must have either been 7th or 8th grade, Mr. Scholler or Miss Koenig, that said you do the little curve so it doesn't get confused with like an x for multiplication. I don't know, but like I can't.
I don't even
Not
use the
do
extra
those?
multiplication.
Now when I'm just making x's like writing words, I don't do them like that. It's just for math. So use that advice if you want. You don't have to, but that's why my x's look that way. Yeah, it just
Actually, it gets 8.
For some reason,
Depends.
X is something.
all right. Excuse me. I'm on my second page. If you want to use the back, that's fine. I don't like to use the back of paper.
Yeah.
It's your it's just, I can't. Yep, I'm not going to tell you not to. I just won't be using the back of any of my papers. Okay, next example.
This is notes. You're supposed to use it. Depending on it. I'm using all those papers, so that means I'm saving the trees.
The trees are going to be cut down into 3.
It does.
The trees have fruits.
Those feelings are gone.
So our variable for this equation is n. I have to change it up every once in a while. So we're going to distribute first. So I'm going to be distributing this -2. And I'm also going to be distributing this -2. Got my wall of equality.
Is that negative n? Yeah.
Yep.
Yeah.
Oh, this right here should be an 8n in the beginning. Sorry. Right here. 8n, 8n. Sorry, forgot the n there. Mostly you guys should be using pencil because I make mistakes. So that way it doesn't mess up your paper so much. It's okay if you didn't. It's okay if you didn't. All right, so this is 8n right here and 8n. So then when I combine my like terms over here, 2n plus 6
Wait,
equals 2n plus 6. Because I made a mistake, so I had you guys add an n back in there.
Oh, okay.
Yep. So who sees it? Raise your hand when you see it.
Oh, they're the same. It's gonna be.
Ben?
What are we seeing?
It is infinite solutions. Why?
Because they're the exact same.
Yep. Infinite solutions is the answer here. And this is because any value will work for n. Yes. When you notice that the left side is identical to the right side, you can stop and just say infinite solutions.
Infinite minis.
Yeah, infinite, infinitely many. I'll accept all variations of that phrase.
Yeah.
Would not accept what?
I tried to put IMS. I just didn't want to take it. I did infinite symbol. Mini solutions. She wouldn't take it. So I just did.
Oops. Here we go. Any value will work.
Too many solutions.
Okay, next example. Pretty sure I have it all accurate this time as with the variables. Looks good.
Yeah, it's gonna be no solution.
What? Could I be that predictable?
Yes.
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 It's a high teacher's
Okay.
Yeah, if you do infinite solutions, then now you're gonna do yes. You're gonna do no solutions.
I'm just glad that you guys know that's a possibility. So after I distribute, I get -7n plus 14 plus 2n equals -5n plus minus 30. And then when I combine my like terms here, I get -5n plus 14 equals -5n minus 30. Some of you may already see that it's no solution because -5 times a number plus 14 will never equal -5 times that same number plus 30. Like it can't happen. But if you don't see it yet, if it's not like sending off any radar, then you can keep working through the problem. If I add 5n to both sides, all I'm left with is 14 equals -30, which is not true. So that is no solution. And you wouldn't even say 0n. The n's are just gone, right? They're just, you don't have any variable left to work with. And right away you should be like, that's not right. Questions? No? So you can have a few different types of answers. You can have one solution, infinitely many, or
none.
or no solutions. What about 0? Can 0 be an answer? Yes. X can equal 0. In that case, it's one solution. Okay, we will stop right there for today.
So if x equals anything above